Water conservation. Water conservation measure is an action, technology, or improved design or process implemented to reduce water loss, waste, or overuse. It can be expressed in the following way: reduction in water loss, water wastage by the behavioral change or device used in domestic work and in daily needs. Reduction in water use accomplished by the implementation of technological advancement in water conservation or water efficiency measures in industrial processing. Improved water management practices that reduce or enhance the beneficial use of water in agriculture production or reduce the irrigational demand. Then we have the benefits of water conservation. Water conservation refers to reducing use of fresh water through technological or social methods. Following are the main goals of water conservation. Sustainability. In order to ensure availability of water for future generations, withdrawal of fresh water from an ecosystem from withdrawal of fresh water ecosystem should not exceed its natural replacement rate. Then we have the energy conservation. Water pumping, delivery, and the wastewater treatment facilities consume a significant amount of energy. Effort should be made to use efficient and cost effective methods. Then we have the habitat conservation. Minimizing human water use helps to preserve freshwater habitats for local wildlife and migrating waterfowl, as well as reducing the need to build new dams and other water diversion infrastructure. Then we have the adoption of water conservation and water harvesting techniques. Water conservation, water harvesting at macro micro level leads to sustainability in water sector for mitigating water scarcity and drought effects. India is characterized with wide variations in the physiographic, climatic, soil, environmental, and the socio-economic conditions. Therefore, rainwater harvesting technology is highly location specific. The various rainwater harvesting practices in vogue may be broadly grouped as in situ retention of rainfall on the land itself by the agronomic mechanical measures, harvesting surface runoff from land surface and storage for the latter use, diversion of perennial surface subsurface water source in storage surface, that is rooftop rainwater harvest. The in situ harvesting practices include bunding and terracing, vegetative barriers, contour bunding, contour ditching, leveling, contour farming, cover crop, and mulching. Conservation, tillage, and deep plowing. The surface runoff water harvesting can be achieved through nadis, that is the dugout ponds, tankas, khadins, ahars, havelis, divergent bunds, and rooftop rainwater cisterns. Stream flow runoff. Harvesting is practiced through nala bunding, check dams, stop dams, bandaras, percolation tanks, ponds, and nadi, subsurface dams, barriers, diaphragm dams. Bandaras are used for subsurface flow harvesting. Indigenous rainwater harvesting and conservation techniques adopted in different parts of the countries, depending on the agroclimatic conditions, have been discussed. The water conservation in various factors, namely domestic, industrial, and agricultural, needs to be practiced vigorously for long-term sustainability. Different water conservation strategies for each sector need to be identified and implemented. Then we have the domestic water conservation. Water conservation programs are typically initiated at the local level, either by the municipal water utilities or local governments. Common strategies include public education campaigns, social water awareness, progressively charging higher prices, increase in water use, subsidies for shower head and toilet retrofits, and seasonal restrictions on lawn sprinklers. Cities in dry climates often require or encourage a natural landscaping in new homes to reduce outdoor water usage. One of the fundamental conservation goals is universal metering. Water metering can reduce water consumption by 20 to 40%. In addition to raising consumer awareness of their water use, metering is also an important way to identify and localize water leaks. Optimization of water use by personal habits. Do not waste water just because someone else is footing the bill. Conserve water because it is the right thing to do. Do not leave the tap running while brushing your teeth or shaving. Open it only when you require it. Using a washing machine that does not consume too much water. Water coolers require a seasonal maintenance check-up. For more efficient cooking, check your pressure cooker annually. Soak your pots and pans instead of letting the water run dry cleaning. Do not water your lawns on windy days. At the end of the day, if you have water left in your drinking water bottle, do not throw it away, pour it over some plants. Reducing water losses in the water supply and sanitary fittings. Repair dripping valves while replacing washers. If your valve is dripping at the rate of 1 drop per second, nearly 8,000 liters of water per year will be wasted, resulting in increase of the cost of water and sewer utilities. Low flush toilets, composting toilets, and the waterless urinals help in considerable water saving. Western toilets use large volumes of the water. Low flow shower heads, also called energy efficient shower heads, should be used. Faucet aerators break water flow into fine droplets to maintain a wetting effectiveness while using less water. They reduce splashing while washing hands and dishes. When washing dishes by hand, do not let the water run while rinsing. Fill one sink with wash water and the other with rinse water. Reuse and recycling of water used in non-consumptive requirements. Drain water instead of disposing of may be used for watering a plant or garden or cleaning. Reuse wastewater to purification at a water treatment plant. Utilize the water used for washing the vegetables and fruits for irrigation of flowers and ornamental potted plants or for cleaning. Then we have the industrial water conservation. Water is essential to our health and health of our economy. As a major user of this precious resource, industry has an important responsibility to practice water conservation techniques which can provide immense benefit by reducing the use of water. Industries can protect the environment and gain a competitive edge by reducing their own cost of doing business. Water used for industries, metal, wood industries, paper, chemical, textile, and oil are major users of the water. Probably every manufactured product uses water during some part of the production process. Industrial water use includes water used for fabricating, processing, washing, diluting, cooling, or transporting. A product incorporating water into a product or for sanitation needs within the manufacturing facility. Then we have the food, paper, chemicals, refined petroleum, or primary metal industries use large amounts of water. Earlier, the water requirements of the industries in India was very small compared to demands of other sectors. With the rapid growth in population coupled with overall economic development due to industrialization, water requirement for industrial sector has increased manifold. When industrial demand is concentrated at a specific location, the available water resources are under severe stress. Thus, water availability is a major factor for locating an industry at a particular place. Non-availability of good quality water has forced a number of industries to shut down. Industries require water for various purposes, most of which are non-consumptive, thus making refuse through recycling and other conservation measures possible. Techniques for achieving water conservation. The amount of water consumed for a product varies widely depending upon the process used, plant efficiency, technology employed, degree to which water is recycled, and other factors. There are no fixed norms of the water demand of industries. However, based on the technology used, selection of the plant and process, practice in providing maximum recycling to reduce demand and pollution, a range of values is specified. The following interventions help in conserving water. Reusing or recycling water when most of the water used is non-consumptive. Avoiding single-pass cooling unless the water is reused. Use of low-flow plumbing fixtures. Developing site-specific conservation plans for large facilities. Technology improvement, reuse, and other forms of demand management need to be given much more emphasis. rather than the traditional supply side oriented approaches in the past. Waste utilization technologies, clean production technologies with emphasis on the waste minimization should be encouraged for adoption, and hazardous waste treatment and disposal need to be so planned and sited as to protect people and environment from adverse impacts. Then we have the policy for industrial water conservation program. Water use management is necessary to conserve our precious natural resource, in which both public and private sectors have an important role to play. The water use efficiency programs reduce water demand, affect water saving and the wastewater treatment, reduce environment impact, and sustain water quality. Industrial water conservation programs benefit the industrial owner and managers in terms of enhancing their knowledge on efficient water use practices and effluent disposal, water auditing and accounting techniques, technological advancements in industrial water and the wastewater treatment, and industrial legal issues, industrial water conservation, optimization, and rainwater harvesting, need for efficient and innovative water use strategies. In view of scarcity of freshwater sources as well as the pollution hazards, following strategies on water conservation and management in relation to industrial sector need to be pursued. Industry should be classified based on their freshwater requirement as highly intensive, moderately intensive, etc. Water availability should be one of the main criteria while deciding the location of new highly or moderately water intensive industries. The Ministry of Industry is in consultation with the Ministry of the Water Resources should fix upper limits of water requirement for the production of various industrial commodities. And we have the substantial water and the cost savings could be achieved by treatment of the wastewater and changing industrial processes. The existing system of subsidies and the tax structure on investment in pollution control, water conservation, and the water recycling technologies need to be periodically reviewed. A significant and punitive variable tax needs to be imposed for creating pollution. Tariff rates needs to be prescribed to force industries to introduce technological interventions leading to reduced use per unit production. For effecting maximum conservation, production processes have to be modified to have lesser generation of effluent water. Pollution controlling and the wastage reduction policy. Selection and the zoning of industries associated with the potential risks, especially those releasing toxic waste, need a thorough analysis and planning before they are set up in any water basin. A policy zoning the water basins according to the types of industries, quantity of water consumed or discharged needs to be laid down. Minimum national standards evolve while the CPCB, Central Pollution Control Board, based on the minimum treatment concepts have to be strictly followed while clearing proposals for locating industries in polluted stretches of the water bodies. The common effluent treatment plant CETP schemes have already been implemented in some states. States may also have to come out with their industry policy based on availability of water in certain sectors in industry. There should be a comprehensive and periodic water consumption and discharge audit of industries for effective management strategies. Wastewater recycling through industrial eco parks. This involves the creation of artificial wetlands using aquatic plant root zone system to treat sewage waters up to minimum levels for recycling in the irrigation and the horticultural sectors and possibly some industrial estates. The system utilizes the roots of certain types of plants such as duckweed, water hyacinth, pennywort, etc. They help in the growth of bacteria which utilizes the nutrients present in the effluents and for the transfer of oxygen. Then we have the industrial water conservation and need of the hour. An industry not only results in the increased water use and considerable water discharge to the hydrologic system but also change characteristics of the Surface or groundwater resource. Therefore, water resource utilization, conservation, and the reduction or elimination of the waste discharges should be practiced effectively and realistically for long term sustainability. Then we have the agriculture water conservation. The agriculture sector is in the mainstay of economy as agriculture consumes over 70% of the fresh water. It is absolutely essential that water is efficiently used and conserved in order to command more area with limited water resource. The share of water in agriculture is likely considerably decreased due to competing demand from other users like domestic and industry. Efforts should be made to use very drop of water efficiently for maximizing crop production. Farmers should be forced to grow more water efficient crops and adopt less wasteful irrigation techniques. Water used in agriculture, surface and groundwater resources in India have been exploited to the maximum extent and there is no further possibility to enhance it. The groundwater levels in the most parts of the country have been depleting due to the overpumping of groundwater for meeting demand of high water requiring crops. The situation has been further compounded due to erratic rainfall distribution and groundwater development exceeding the natural recharge. It takes an enormous amount of water to produce crops, that is 3 to 5 meter cube water to yield just 1 kg of rice and 1 meter cube water to produce 1 kg of wheat. It is therefore of paramount importance to alter the existing cropping pattern from high to low water requiring crops and use the water resources including rainwater in the most optimal way by adopting efficient on-farm water management practices. Water conservation techniques for agriculture. Water use efficiently needs to be enhanced by using minimum water resulting in maximum productivity. In irrigated agriculture, water needs to be used as efficiently as possible along with adoption of recommended packages of practices such as the use of nutrients, pest disease and weed control so that it results in the maximum production. In rainfed agriculture, the soil moisture needs to be stored and conserved for maximizing the crop productivity, which is presently very low. As most of the area in the country is still rainfed, the crop productivity in such areas needs to be enhanced and sustained in order to meet the food requirement of ever growing population of the country. In both irrigated as well as rainfed areas, utmost effort should be made to use existing water resources, including rainwater, efficiently and optimally and conserve the soil moisture for long term use. In irrigated agriculture, particularly in the semi-arid and arid regions, the following measures help in reducing water losses and to conserve soil moisture. Mulching, that is the application of organic or inorganic materials such as plant debris, reduces evaporation losses and improves soil fertility. The field should not be left fallow for long periods of time in order to reduce the water losses by evaporation. Plowing helps in conserving soil moisture and retaining more water, thereby reducing evaporation. Shelter belts of trees and bushes along the edge of agriculture fields slow down the wind speed and reduce evaporation and erosion. Planting of trees, grass, and bushes break the force of rain and helps rainwater penetrate the soil. Artificial surfaces such as netting, surface traps, or polyethylene sheets can be exposed to fog and dew. The resulting water can be used for the crops. Contour farming is adopted in the hilly and the lowland areas of the paddy fields. Farmers recognize the efficiency of contour-based system for conserving soil and water and the proper land labeling, use of the well-designed efficient methods of irrigation depending on soil, crop, topography, water source, climatic, etc. and the proper irrigation scheduling, depth and time of irrigation help in improving irrigation efficiency and thus considerable water saving.